Hello, and thank you for taking the time to learn about QuickClipXO. This tutorial will take you through all the major parts of the QuickClipXO interface. This is the first in a group of tutorials about Drastic Technologies digital disc recorders. QuickClipXO is the primary interface to the Drastic Typhon, Griffin, and Dragon series digital disc recorders. It is written in Java and controls the disc recorder through the network. This means that not only can it be run directly on the DDR, but also from any Windows, Mac, or Unix system on the network. QuickClipXO can be divided into three major functional areas: the view, the transport, and the operational mode areas. The view is contained in the top two-thirds of the interface. It is controlled by the view selector buttons on the right-hand side. There are 5 views: the main view, clip view, setup, video setup, and audio setup. The main view places a video window in the view area. This will display the currently playing video or the incoming video if in stop or record. Alternately, the main view may contain a picture icon representing the current clip if you are running remotely, or if the video is being displayed on the secondary VGA output. The clip view displays picture icons or picons and information for the currently loaded media clip. The current clip is indicated by the square selection box around one of the picons. The property and metadata lists below will correspond to that media clip. The property list describes the main physical attributes of the clip. This will include width, height, frame rate, encoding type, and audio information. Next to each of these elements is the same setting for the digital disc recorder hardware. Normally these two settings should match for seamless real-time playback. If there's a mismatch, the elements that are different will turn orange to indicate a possible problem. If there are differences, the DDR may not be able to play back this media file properly without being reconfigured. The metadata list includes all known metadata about the media file. These metadata elements may be read from the file itself, or from the information stored in the sidebar XML file. There are 112 possible metadata elements in the 3.0 release. They include things like locators, comments, ownership, and copyright information, as well as production-specific information like shot, reel, scene, and take. Real-time data such as timecode, user bits, and key code are also maintained, but they are displayed in the transport section below. The setup page contains the basic configuration and information area for the DDR. The system info area on the left contains the most important status information. This includes the type, version, and total storage attached to the DDR. The total storage and how much of that storage is free is available in both terms of size and time at the current recording type. The system info page also has a real-time status of the video, audio, and reference inputs to the DDR. The storage format area is used to configure how the DDR will record the next media file. To configure the unit, start by selecting the file type you want to record. This includes all the common file types like DPIX, MOV, AVI, and TIFF, as well as less common types like AvidDSGen, YUV, header RAW for compression systems, and uncompressed Windows media. Next, the video input type should be selected. Depending on the file type selected, there will be a number of compression options. The most common are 10-bit RGB, 8 or 10-bit YCRCB, and 8-bit RGB, but other compressed types such as IMX D10MPEG are also supported. Once the compression type is selected, you can select the bit depth. Finally, there's the video standard selection. The Drastic DDRs support a wide range of video standards including standard definition, 720p high definition, 1080i, P and SF high definition, and 2048 digital cinema standards. Depending on your particular DDR, HD-SDI 2K film transfer and real-time 2K playback with center cut HD may also be supported. If you are running the DDR as a DVI playout device, you can also play back at VESA, 1K, 2K, 4K, as well as custom resolutions and frame rates. Finally, you can set the record folder, look at the debug log, or access the main help file here. Alternately, the help file is also available by pressing the F1 key. The video setup can contain a large number of settings depending on your hardware. For the modern uncompressed DDRs, the active elements will generally only include the video input and output area, as well as the reference lock and up-down convert areas. The video input will allow you to select the standard digital SDI input, or if available, any analog inputs. With the Drastic DDRs, all video outputs are always on, but where more than one analog video type share the same cables, the video output drop-down may be used to select what type of analog output is active. The lock area is used to phase lock the video output to an external signal. For DDRs, it is always recommended that they are locked to the input signal when being used as a recorder. When being used as a source, the lock can be off, locked to input, or locked to an incoming reference signal. The up-down convert area controls the analog output and can also control a secondary digital output. There are 4 main types of conversion. Direct sets the output to the same video standard and size as the DDR is set to. The 2SD setting will output NTSC or PAL video depending on the closest frame rate that matches the DDR setup. The 2HD-720 will convert to HD-720p 50, 5994 or 60 Hz, and 2HD-1080 will convert to 1080i 50, 5994 or 60 Hz, depending on the best frame rate match to the DDR's main setup. If you are down converting to standard definition, the analog output may be set to composite, component, or RGB. If an aspect ratio conversion is required, it can be set to letterbox, crop, or anamorphic. If you are up converting to HD, the analog output may be set to component, RGB, or VGA. If an aspect ratio conversion is required here, it can be set to anamorphic, pillar box, zoom 16:9, letterbox, or zoom wide. If the secondary output is not used, as is the case in single link, it will mirror whatever the up-down converter's analog output is set to. Even if the secondary output is in use, as is the case in dual link, you can override it. By clicking on the Disable Dual Link Out, the first digital output will be changed from half of a dual link pair to a single link connection. The secondary digital out will then be set up to match the analog down convert. There's also a superimpose button available. Clicking this button will cause the timecodes and user bits to be overlaid on all outputs. Keycode and ink code overlays are also available if selected in the local config setup utility. Audio setup also has a large number of controls, but on uncompressed DDRs most of these will be inactive. You can select which source your audio will come from. This includes embedded audio, XLR or BNC ASCBU, and on some DDRs, balanced analog sources. The audio outputs are always on. The audio setup also allows you to use an audio channel to read and generate standard SMPTE longitudinal audio timecode, also known as LITC. The last button inside the view selector is the How Do I button. This button is special because it does not actually change the main view, but instead brings up a web page, which has short descriptions of the most common operations you use on a day-to-day basis. These include input, output, and video setup, as well as various control scenarios and third-party setup recommendations. This is very handy when you need to quickly look up how to do an operation you may not have done before. Finally, at the bottom of the view selector area, there is a drop-down combo that selects the current DDR channel you are working with. On most DDRs, this drop-down will only include the one internal DDR channel and possibly an external VTR. With the Typhon 2, or VVW 5004, there will actually be multiple channels available for control, and this is where you would select the one you want to work with. Below the view selector, there is a button labeled Audio Levels. Clicking this button will replace the view selector with audio level meters. The button name will also change to View Selector, and clicking it again will bring you back to the selector. The transport area of QuickClipXO lets you control and monitor the digital disc recorder's internal channels or other external devices connected to the DDR, like serially controlled videotape recorders. There are 3 parts to this area. From left to right there is the Edit Selections, the Transport Controls, and the Current Status areas. The Edit Selection buttons allow you to turn on or off video and audio channels for the next record. The buttons in the transport area include standard motion commands, like play, pause, play reverse, step frame, skip forward and reverse, and fast forward and reverse. The Stop EE button displays the current input. The Eject button will eject the tape when controlling a tape machine. The Record button will prepare or start a recording of the input to the disk using the current file type. Above the transport buttons there's a slider and a button labeled Pause. This Pause button controls the function of the slider. The possible modes are Pause, Jog, Shuttle, and VAR. When the slider is in the pause mode, moving it will change the playback position within the clip. For short clips, the start of the slider represents the start of the clip, and the end of the slider, the end of the clip. For clips over 1/2 hour in length, the slider represents a 40-minute segment of the clip with the even half hour centered in the slider. This allows fairly fine control of the position, but still allows access to subsequent or previous half hours by dropping the slider thumb control at the end or the beginning of the slider. The jog mode can be used for fine, slow-speed motion to find particular areas or frames. Left-clicking and holding the mouse pointer anywhere within the slider area will cause the playback to start at speeds ranging from -100% to 100% of normal play speed. Moving the mouse while the button is held down will change the speed. Releasing the mouse will cause the playback to immediately pause. The shuttle mode is like the jog mode, except the speed range is from 10 times play to -10 times play. Clicking and holding the left mouse button anywhere in the slider area will allow you to vary the speed. Releasing the mouse will cause the playback to pause. The VAR mode is designed for constant off-speed playback. Clicking the left mouse button in the slider area will start the playback between -100 and 200% of play speed. Releasing the mouse will cause the playback to continue playing at that speed. The transport status area displays position, time code, and state information. There are 2 time codes available at all times. The time code source can be selected by clicking on either of the time code source labels. Normally, the upper time code will be left on CTL, which is the absolute, zero-based time code of the media file. The lower time code may be changed depending on application. The supported types are CTL, or absolute position, LITSI, which is the SMPTE audio time code, VITSI, which is the vertical blank time code, key, which is the film's key code, and ink, which is the film's ink code. Depending on your media file, some of these types may not be available. To the right of each time code is the time code type. For this demonstration, we are in 1080i 50 Hz, so the time code type is PAL. Drop frame, non-drop frame, film, and 2398 time code types are also supported in their appropriate frame rates. If more than one type of code is supported, as is the case in NTSC, you can switch between them by clicking on the DF or NDF label. Below the upper time code is the speed indicator. It is displayed as a percentage of play speed, 100% being normal forward play. To the right of the lower time code is the time code source user bits. Finally, the middle left position is the alarm area. When the DDR detects a problem, it flashes a code here. If I remove the video input to the DDR, the words IN and ODD flash in that space. This indicates there's a problem with the video input and the audio input. At this point, we only know that there is a problem and not the specific nature of the problem. In this case, the video input is missing, but it could also be set to the incorrect video standard. By clicking on the Setup button in the View selector, we can check the input and audio status. Reattaching the input causes the status to return to normal and the warnings to stop flashing. Other codes include REF for reference input, DISC when the disk starts getting full, and NET for network communication errors. The bottom section of the QuickClipXO interface is the operations area. There are many ways to use the Drastic DDR in production workflows, but the QuickClipXO GUI was designed to facilitate 5 of the most common operations. These are clip handling, telecinion editing, conform, batch capture, and batch output. We will start with clip handling. Clicking on the clip button in the mode selector will display the clip bin and timecode editing block. QuickClipXO always has one clip bin open. This bin is maintained on the disk recorder as a text-based EDL or log file. Clip bins can be loaded or created using the File, Open New Clip Bin button. Each media file will have a line in the clip bin which contains its short name, duration, long name, and location. Clicking on the line will load the clip and display its first frame. If the clip view is active, in the View selector, the clip's metadata information and picture icon will also be displayed. Every media file in the disk recorder has 2 names. One, the long name, is the same as the file name on the disk. The second, the short name, is set by the user and is used to allow access to the clips from VDCP and Rodetics automation systems that do not support long file names. Because of this legacy requirement, all short names are limited to 8 characters in length. The long names are only limited by the file system. Media files are added to the clip bin by clicking on the Add Media button. This will bring up a file browser that can be used to select the media file. In the case of an image sequence, clicking on any image in the sequence will load the whole sequence as a single clip. Once a media file is selected, the Add Clip Options dialog will allow you to set the short name for the clip. Clicking Add will add the clip to your bin, select it, and load the first frame. It should be noted the sidebar WAV or AFF audio files and metadata information will be automatically loaded with the video file and do not need to be loaded separately. Now, the dialog I just used to add the file works using the local file system. If you are running QuickClipXO remotely, you will not have direct access to the local file system. In this case, QuickClipXO will use the disk recorder's HTML-based file browser. This file browser works very much like the local file browser without requiring local access. Other advantages are that sequences of images are condensed into a single line, and production information is displayed when the mouse is placed over a file entry. Clicking on the clip and then the Add Clip button will bring up the HTML request for a short name and then add the clip to the clip bin. Once the clip has been added to the bin, it will contain all of the video in the original file. In some cases, only part of the video will be needed, or it may be convenient to break it into smaller logical units. Virtual subclips can be made by setting in and out points on the original clip and giving them a new short name. In the timecode editing block, clicking the In button will set the start time to the current time. Setting the Out button will do the same for the end. As with most systems, this out point is not actually included in the edit, but instead describes the frame after the last visible frame. The In and Out may be edited manually by clicking in the timecode edit boxes and using standard number and editing keys. The in and out points can be checked by clicking on the Q buttons to view their frames, or by clicking on the Prev button to preview from the in to the out point. Once you are happy with the subclip, clicking on the Make Subclip button will let you give the new clip a short name and add it to the bin. This new clip does not actually create a clip on the disk file system or take up any space. It simply maintains pointers to the original file, which it uses to act as if a new clip had been made. Normally, when working with individual clips, only the clip video is available for playback. This means that a controlling device like an editor that requires a pre-roll to synchronize multiple devices cannot use all the video to edit because part of it is used in the pre-roll. To alleviate this problem, there is the pre-roll mode. Clicking on the pre-roll checkbox will automatically add 1 minute of black video and silence to the start and end of each clip. In the pre-roll mode, the actual clip begins at 1 minute. Clicking on the clip will load it and sync it to the first frame of actual video. When the controller pre-rolls the discs to 6 seconds before the edit, for example, it will now have black video to play. It can then bump the disc recorder into sync with the other equipment and edit from the start of the actual clip. Another useful tool is the playlist. Clicking on the playlist checkbox will move the clip bin to the right and display an empty playlist in the center of the operations area. Playlists may be opened or saved locally as EDL text files, or they can be created by adding clips from the clip bin. Once the playlist is finished, clicking the Playlist button will start playing from the beginning of the first clip in the list until the last clip finishes playing. If the Loop List checkbox is checked, then it will seamlessly loop the entire list until the Stop Playlist button is pressed. The film mode is actually a special clip called : film in the clip bin, which is used for telecine recording, editing, and read-while-write operations. To use the film mode, simply click on the : film clip. If there is no film clip in your bin, one can be loaded or created by using the File Open New Film button. The concept behind film space is to destructively record a series of images so that at the end of the session only the final corrected images are left. This is achieved by creating a virtual 24-hour timecode space for the editor or colorist to record into. Simply by seeking and editing as you would with any normal tape-based deck, the images are written or overwritten to the disk depending on the timecode they are recorded at. On the disk, the film space has an informational file, which has the extension .film, and one or more directories into which the images and audio will be written. The film space I have made has a 1-second edit at 19 hours and 10 seconds. If I go to the 19 hours 0-minute directory, you will see 25 images starting with the frame number 250. If my next edit was at 19 hours 11 minutes, then the image sequence would be extended and the first edit left intact. If I was not happy with the look of the first edit, I could overwrite it by starting my edit before or within the previously recorded section. There are no limitations on where or how long edits may be made, and at the end of the session, only the good frames will remain to be used in the rest of the DI process. Conform space is a cuts-only conformed edit space. To select conform mode, click on the Conform button in the Mode selector. To load an existing conform space or create a new one, click on the File Open New Conform button. In conform mode, the center list is an edit decision list which describes each of the edits that make up the conform space. Just as if you had recorded the edits onto a videotape recorder, each of the edits listed will appear at the time code listed in the timeline column. On disk, they will actually have individual media files or image sequences, but the conform EDL is used to allow them to be treated as if they were one long file. Conform space is normally created in one of three ways. 1. Using an editor, the conform space may be treated as a videotape recorder, and each edit recorded onto the DDR just as you would with a VTR. Each edit in this mode will be recorded as a separate media file or image sequence, and the relationship and edit time will be maintained by the edit decision list. 2. The From VTR mode may be used to load or create an EDL, which will then be batch captured from the original source tapes. There will be more on this method later in the tutorial. 3. Clips may be manually added into the conform space from the clip bin or directly from the file system. When adding clips, they may be positioned, trimmed, and edit channels may be changed. Another interesting feature of the conform space is that sections of edits may be used to create virtual subclips for the clip mode. Simply set an in and out point and click the Make Subclip button. The newly named clip will then appear in the clip bin with all of its edits intact. Clicking the From VTR button in the mode selector will take you to the batch capture operation. Once clicked, an options dialog will let you set the first reel name, record endpoint, and optionally add heads and tails to your captures. Once dismissed, the center operation area will be replaced by an empty list. Entering either of the VTR modes causes the transport section above to control the external videotape recorder instead of the internal channel of the DDR. QuickClipXO supports reading and writing of CMX, Grass Valley, Sony, and Avid Log Exchange format EDLs. Once loaded, the list is sorted by reel name and then by timecode. The transfer may be made by right-clicking on the list or by using the transfer button and selecting what you would like to transfer. Each entry will be captured to the disk, and tapes will be automatically ejected and requested for each new reel. If you do not have an EDL, one can be created in QuickClipXO. Clicking the EDE button in the lower left will put the internal channel into stop pass-through and display the input on the main view. The VTR can now be controlled using the transport buttons and slider. Once you have found the in and out points for the area you want to capture, they can be set in the timecode edit block on the right. There are also edit boxes for clip name, reel name, and comments. Clicking the New Clip button will add the edit to the list. To modify an existing edit, double-click on it in the list, and the Set Clip button will light up. Make the necessary modifications, and click the Set Clip button to write it back to the list. So far we've been capturing clips as individual files into the clip bin. If you are capturing from an EDL using source tapes, you will probably want the captures to appear as described on the record side, as well as being able to access each of the edits independently. Changing the int channel mode from clip to conform will cause the captures to be added to the conform mode as they are captured. This means that at the end of the capture, a virtual record tape matching the record side of the EDL will be immediately available for further post-production. The final operational mode is the 2VTR mode. This mode is used to put media files or conform media back out to videotape. Clicking on the 2VTR button in the mode selector will bring up the playlist in the center of the operations area. Playlists may be saved or loaded from your local machine, or may be made by adding clips from the clip bin, which is now on the right, to the playlist. If you need to output a section of the : film space, or a section of the conform space, they are also available. The conform space is represented by a special clip called VTRTC. When outputting virtual clips that are 24 hours long, you will need to edit them down to the interesting area once they are added to the playlist. First, drag the clip from the clip bin to the playlist. Next, right-click on the entry in the playlist and select Edit Row to bring up the Edit dialog. Change the clip in and clip out to the area you're interested in transferring and click the Change button. Once you have your list, you will need to set a starting point on the tape where you would like the media files to be recorded to. Changing the In Point VTR timecode edit box will set the starting point. Once changed, the record points of each of the edits will be updated to represent their new locations on the videotape. Clicking the Test Play button will play the list without recording it to tape. Pressing the Record to VTR button will pre-roll the videotape, begin an edit, and record all the media files to the tape as a single edit. Once recorded, you can use the Save EDL button to save your playlist as an EDL to go with the tape and describe the material at each edit. This completes the basic tutorial on the QuickClipXO interface. For more information on QuickClipXO, Drastic digital disc recorders, and other Drastic products, please explore these links. Thanks for watching and have a great day.